Before we dig into the assertion, it's essential to initially grasp what atomic fuel petals really are. The Huge Hadron Collider, LHC, work by CERN, is a 17-mile ring made out of superconducting magnets. It remains as the world's biggest and most amazing iota smasher, addressing the zenith of human accomplishment. Truth be told, it is so strong that it can reproduce the specific states of the universe's first minutes. Anyway, could the machine that plans to uncover the secrets of the universe possibly hold the way to something genuinely unique? Established in 1954, CERN is one of the most famous research organizations overall, with 23 member nations and various researchers. It fills in as a center point for collaboration and development. While the LHC is CERN's essential undertaking, it is just a piece of a vast network of fuel petals and exploratory investigations. This framework is designed not for engines or people, but for subatomic particles in a trial of perseverance and the actual texture of space itself. The LHC speeds up protons close to the speed of light, controlling them into an impact course that reflects the energy delivered during the Big Bang. These impacts create temperatures far hotter than the sun's core. A huge array of magnets coordinates the protons on their way, while modern cooling systems keep the magnets at temperatures lower than space. The radiations in the LHC are made to crash at 4 particular areas across the gas petal ring, interacting with 4 explicit molecule identifiers: Atlas, CMS, ALICE, and LHCb. Every one has a unique capability, concentrating on various features of particle physics. Together, they go about as tremendous cameras capturing pictures of these impacts. Researchers then break down the subsequent particles, looking for indications of the subtle Higgs boson, also known as the God particle, and other irregularities that could reveal insight into the basic parts of the universe. By zeroing in on the minuscule, we open bits of knowledge into the macrocosmic world. Yet, with each answer, new inquiries emerge. With each discovery, another test surfaces. The LHC isn't simply a scientific instrument. It is an image of human curiosity and progress. It addresses our tireless quest for understanding and our longing to unlock the major forces that govern our universe. Anyway, as we stretch the boundaries of our knowledge, we must also face further existential questions. What dangers lie in testing the obscure? Could our mission for information unintentionally release forces beyond our control? Inside CERN, where the limits of human comprehension are continually extended, a chilling disclosure has surfaced, causing even the most experienced researchers to stop. Brian Cox, a former CERN researcher and an authoritative voice in the domain of particle physics, recently shared a statement that has both enraptured and disturbed the world. His words repeated with disturbing clarity. The reason for CERN's LHC is to reenact a little Big Bang. Indeed, you heard accurately, a miniature version of the very event that birthed our universe. The physicist moreover explained the implications of this objective, highlighting the LHC's gigantic potential to make heavy revelations, including revealing the secrets of the Higgs boson and delving into the cryptic universe of dark matter, which comprises a massive part of the universe. Imagine holding the power of creation in your grasp, the ability to call the actual substance of the universe. It's an appealing opportunity, but one full of risk. The Little Big Bang is not just a theoretical concept. It is a tangible reality within the LHC. The extreme temperatures, pressures, and raw energy mimic the conditions present at the dawn of the universe. It's like standing near the very edge of recorded history, witnessing the initiation of existence itself. Yet with such power comes incredible responsibility, and the pressing question remains: what if something goes wrong? Indeed, something did go wrong. In 1978, Russian physicist Anat Borsky encountered a mishap that could forever alter his life. While working at the U-70 synchrotron at the Institute for High-Energy Physics in Pino, Russia, a breakdown caused a proton beam to strike him. The beam, with an unbelievable force, went through his skull, entering the back of his head and exiting through his nose. His experience was unnerving. He saw a flash brighter than 1,000 suns, but had no immediate concerns. The proton's path left behind a trail of destruction, burning tissue and bone. Yet, amazingly, he stayed conscious and even walked to seek treatment. The result was agitating yet strange. The proton beam caused limited tissue damage, leading to partial hearing loss in one ear and facial paralysis on one side. Astonishingly, Borsky's mental capabilities remained unaffected, and he continued his career in medicine. This occurrence serves as a stark reminder of the tremendous power and potential risks inherent in particle accelerators. The dangers associated with machines like the LHC shouldn't be underrated. The chance of disastrous consequences, where the very fabric of life is changed, isn't just the stuff of sci-fi, but a real concern voiced by respected researchers. One of the most terrifying and intriguing issues surrounding the LHC's tests is the potential creation of a miniature black hole. Black holes are areas in space where gravity is so intense that even light can't escape. These cosmic vacuum cleaners devour stars and are mysterious entities lurking in the shadows of our universe. The possibility that the LHC could create one of these phenomena, even on a small scale, is both striking and alarming for the public and scientists alike. Could this black hole ever grow wildly and eventually consume the Earth from within? CERN researchers have reassured the public that any black hole created by the LHC would be unstable and would vanish very quickly. Still, the mere possibility of such an event has sparked discussions, fears, and awe at the power humankind wields. It's essential to understand how the LHC could create a black hole. The answer lies in the fundamental mechanics of particle accelerators. When protons crash at near light speed, the energy created is so tremendous that it distorts the very fabric of space-time. Imagine a trampoline stretched tight, and then a heavy object is dropped onto it. The fabric twists, and if the object is heavy enough, it creates a well deep enough to draw anything nearby into it. This serves as a metaphor for what could happen inside the LHC. Inside the realm of quantum physics, where the laws of the universe are often strange and bewildering, a theory exists suggesting that there could be more dimensions hidden within our existence. If these dimensions do exist, the LHC's experiments could tap into them, creating a gravitational well that forms a tiny black hole. This strange interaction of particles has even caught the attention of prominent scientists, including the late Stephen Hawking. In his writings, Hawking warned of the potential dangers of the Higgs boson at incredibly high energy levels. Such instability could lead to a catastrophic event known as vacuum decay, an event that wouldn't just destroy the Earth, but could potentially erase the entire universe. The eminent cosmologist and physicist Sir Martin Rees has also voiced concerns about CERN's experiments in his book Our Final Hour, where he explored the dangers associated with particle accelerators, including the LHC. The idea of hidden dimensions and the potential for the LHC to access them has captivated both scientists and the general public. While much of this remains speculative, the possibility that the LHC could provide a glimpse into these realms has sparked curiosity and concern in equal measure. The energy levels generated by the accelerator are unprecedented, and it's within this extreme environment that some theorists suggest particles might interact in ways previously unimaginable, potentially opening new doors in our understanding of the universe. However, even as researchers push the boundaries of what is possible, questions about the risks remain. If the LHC were to inadvertently open a portal to another universe or dimension, what might it unleash? Could it lead to a catastrophic shift in our own reality, or could it open the door to new knowledge and scientific breakthroughs? The possibilities are both exciting and unsettling, raising philosophical and ethical questions about humanity's role in the vast cosmos. Despite these concerns, the pursuit of knowledge drives scientists at CERN and other research institutions worldwide to continue their work. The search for the fundamental building blocks of the universe, the quest to understand dark matter, and the exploration of quantum physics are all part of an ongoing journey. But as they venture into the unknown, it's crucial to weigh the potential dangers alongside the rewards. In the world of particle physics, where discoveries can alter the very fabric of reality, caution and curiosity must coexist. As technology advances and our ability to manipulate the subatomic world grows, so too does the responsibility that comes with it. The LHC is just one of many tools in humanity's scientific arsenal, but its potential to shape our understanding of the universe makes it a powerful symbol of both our achievements and our vulnerability. Whether it's creating mini black holes, revealing the secrets of the Higgs boson, or perhaps even opening a doorway to another dimension, the future of particle physics holds endless possibilities, both thrilling and terrifying in their implications. The questions raised by the LHC and similar experiments challenge us to consider not just what we can do, but what we should do. How far should we push the boundaries of our knowledge? And at what cost? In the quest to unlock the mysteries of the universe, we must be mindful of the unknowns that lie ahead. For every discovery that brings us closer to the truth, there may be unintended consequences waiting just beyond the horizon. And while humanity's thirst for knowledge may be insatiable, it's essential to remember that the universe itself is a vast and unpredictable place, full of forces we may not fully understand or be able to control. Ultimately, the story of the LHC is a story of human ambition, scientific progress, and the eternal quest for understanding. It's a reminder that as we explore the deepest recesses of the universe, we must remain aware of the immense responsibility that comes with such knowledge. The LHC and the experiments it conducts are not just about answering questions. They are about asking new ones, questions that could one day change the way we perceive everything from the smallest particles to the vastness of space itself. In the end, the true test will not only be the discoveries we make, but also how we use them. Whether the LHC uncovers hidden dimensions or new forces of nature, the journey it represents is far from over. And as long as we continue to seek answers, we will undoubtedly find ourselves facing new frontiers, both in science and in our understanding of the universe, and perhaps even in our place within it. Set up are intended to limit potential dangers. Researchers implied in the LHC tests have gone through thorough preparation, and the activities of the collider are checked and looked into at each step. Yet the sheer size of these analyses and their suggestions frequently lead to theory that goes past the domain of science into the domain of legend and guess. While exciting thoughts of substitute aspects or different universes could fuel media stories, it means a lot to note that there is no experimental proof to propose the LHC will open these hypothetical entryways. However, it is valid that some hypotheses propose the plausibility of different aspects. These thoughts remain speculative, and the LHC has yet to show any conclusive confirmation that it is opening such secrets. The LHC's object isn't to demonstrate these speculations. In any case, it is to investigate the fundamental structure blocks of our existence. Regardless of the serious examination the LHC faces from both the academic community and the public, it remains quite possibly one of the most progressive tools we have for grasping and understanding the universe at the most central level. The collider's capability to answer profound, unanswered inquiries about the origins of matter and the forces that shape the universe is unrivaled. These forward leaps could lead to advancements in technology, medicine, and our general understanding of the universe that we can scarcely imagine. As scientists continue to test the subatomic world, they are not simply posing inquiries. They are revising the principal laws of physics as we probably know them. By and large, the LHC's continuous journey through neglected scientific territory reminds us that with great power comes great responsibility. The questions raised by these examinations, questions about the origins of life, the nature of space and time, and even the survival of the universe, require a balance between bold exploration and cautious thought. As human curiosity drives us to understand the universe's most profound secrets, we should always be aware of the potential outcomes, regardless of how impossible they may appear. In the end, the LHC is a reflection of humankind's unwavering desire to comprehend the universe. It represents the forefront of science, where ambitious ideas are tested and groundbreaking discoveries are made. Yet it also serves as a reminder of how little we truly know. Even as we achieve one discovery, it opens the door to countless more questions, many of which we may never be able to answer. The pursuit of knowledge, while a noble endeavor, is not without its risks. As we move forward, we must be ready to deal with the uncertainties that accompany exploring the unknown. As the LHC continues to explore the depths of particle physics, it carries with it the weight of human curiosity, ambition, and caution. Its ability to mimic conditions from the earliest moments of the universe allows us to probe the forces that have shaped the cosmos. But it also places us at the cusp of new, unknown territories, where the outcomes of discoveries are uncertain. At the intersection of science and existential inquiry, the LHC will continue to ignite both awe and concern. The questions it raises about the nature of the universe, the risks of altering its foundations, and the power of human advancement will remain at the forefront of scientific discussion for years to come. As we push forward into this new frontier, we should remember that each great leap forward in knowledge is accompanied by an equally great responsibility. We must proceed carefully, guided by curiosity, caution, and a deep respect for the secrets that still lie hidden within the universe. The world of scientific discovery is a steadily advancing scene, and in the realm of particle physics, few places epitomize this spirit of investigation more than CERN, the European Organization for Nuclear Research. Known for its historic work at the Large Hadron Collider, LHC, CERN is a center where physicists and engineers collaborate to unravel the mysteries of the universe. Recently, several startling revelations have emerged from CERN's research, and the renowned physicist Brian Cox has provided insightful commentary on these discoveries. His perspectives bring clarity to the complex nature of these developments, shedding light on how they may shape our understanding of the universe in the years to come. One of the most significant aspects of CERN's work is its capacity to challenge existing scientific models and open doors to new possibilities. Over the years, the LHC has been instrumental in confirming certain aspects of the standard model of particle physics, while also suggesting the presence of anomalies that defy current explanations. These anomalies are often subtle and elusive, requiring a delicate balance of experimental precision and theoretical investigation to interpret. Brian Cox, with his vast experience in theoretical physics and as a science communicator, has been especially vocal about how these surprising discoveries force scientists to think beyond conventional boundaries. He has often remarked that one of the most exciting aspects of modern physics is that we are living in a time when the questions far outnumber the knowns. These questions manifest as anomalies or irregularities in experimental data that suggest there may be new laws of nature yet to be discovered. Cox frequently discusses the role of the LHC in investigating these oddities. One of the key areas of interest has been the behavior of particles that appear to interact in ways that cannot be fully explained by the standard model. For example, there have been irregularities in the rotation patterns of certain subatomic particles, like the beam meson. These disparities suggest the possible existence of particles or forces beyond the known ones. The implications of such discoveries are profound. They could highlight new aspects, unseen forces, or even the possibility of a completely new framework for understanding the universe. Cox emphasizes that while these findings are exciting, they also highlight how much we still do not understand. He stresses that science advances through a cycle of speculation, experimentation, and correction, with each new discovery building on the last. The abnormalities observed at CERN are not necessarily proof of new physics, but they are undoubtedly signs that current theories may need to be extended or reconsidered to accommodate new data. In his discussions, Cox often points out that these discoveries are not isolated to a single experiment or anomaly. Rather, they represent a growing pattern in particle physics, where unexpected results are becoming more common as experimental technology improves and as physicists push the limits of what is measurable. The accuracy of the LHC's instruments has allowed scientists to observe minute details that were once beyond the reach of experimental capabilities. These small inconsistencies are often the seeds of larger breakthroughs and, at times, challenge the very foundation of physics. Beyond the LHC's immediate scope, Cox also underscores the importance of the global collaboration that makes CERN's research possible. The discoveries at CERN are not the result of isolated efforts, but the product of thousands of researchers, technicians, and specialists working together across disciplines and borders. This collective effort is crucial for making sense of the startling result. The search for new forces or symmetries is a significant area of interest in modern physics. As we push the boundaries of what we know, the possibility of discovering previously unknown interactions or new fundamental forces remains a tantalizing prospect. Such discoveries would not only expand our understanding of the universe, but could also reshape the way we think about the fundamental structure of reality itself. CERN's experiments have the potential to uncover phenomena that challenge the very foundations of the Standard Model. Whether it's through the detection of new particles, the observation of unexpected behaviors in known particles, or the exploration of anomalies that suggest the existence of new forces, the research conducted at CERN has the power to transform the way we understand the universe. These groundbreaking findings could eventually lead to a more comprehensive theory of everything, one that unifies the various forces of nature and explains the fundamental nature of all particles and interactions. Brian Cox, with his expertise in particle physics and his ability to communicate complex scientific concepts, continues to be an important figure in explaining the significance of these discoveries to the public. Through his work, he helps to demystify the world of high-energy physics and bring attention to the importance of the research conducted at CERN. As physicists and engineers at CERN continue to test hypotheses, conduct experiments, and explore new frontiers in particle physics, the discoveries made there will have far-reaching implications for science, technology, and our understanding of the cosmos. In conclusion, the work being carried out at CERN, particularly at the Large Hadron Collider, is at the cutting edge of scientific exploration. It is not just about answering the questions we already have, but also about raising new ones that will drive future research and discovery. The pursuit of knowledge through these experiments is a testament to humanity's curiosity and determination to understand the universe on the most fundamental level. As we continue to push the boundaries of our understanding, we must approach these discoveries with both enthusiasm and caution, recognizing the vast potential for new insights while remaining mindful of the responsibility that comes with such powerful knowledge. CERN, with its state-of-the-art technology, international collaboration, and bold scientific vision, remains one of the foremost institutions in the world of physics. The surprising discoveries, the potential for new particles and forces, and the ongoing efforts to unravel the deepest mysteries of the universe ensure that the journey of scientific exploration at CERN is far from over. As we look toward the future, we can only imagine what new revelations will emerge from the depths of particle physics and how they will shape our understanding of the universe in the years to come.